Okay, now what we are going to do is make a copy of BHA number 5 to BHA number 6. There are two places in the program where we can do that, but this is the place where we can do it in the editing. We can do it on the front part of the screen by selecting the BHA and going through a different process and then pasting it. In that part of the program we can go from one job over to another job, but this copy BHA is obviously just within this one job. Note that there is this button here that says Copy BHA. Before we press that, we want to make sure that we have not already created the BHA that we're going to copy to. And in this case, we see that we have BHA number 5 of 5, and that we don't have any BHA that is listed here. So I'm going to copy BHA. I'll go copy BHA, and it asks me what BHA do I want to copy to, and I go 6. And I hit the tab key, and then I go OK. And it will almost always tell me item not found in this collection. And then it goes to 6, and then I come over to 5, I go back to 6, and everything is fine. It's just a little problem that it has updating the screen there, but the quick way around it is to hit these two arrows and get back on track. Now I'm on BHA number 6, and let's say on BHA number 6 I wanted to change the bit, the serial number. So I'm going to change the bit to this, and maybe the bit has a different length on it, so I'm going to go 1.34, and so I have maybe everything else is the same, and maybe I want to change the motor, or I want to change something else. Say I don't want the stabilizer here, for example. Let's say I want to just eliminate the stabilizer, so I can come to the stabilizer here, and I can select it on the left-hand side, and I can press delete, and you'll notice that it's taken out of the picture. And maybe I'm going to take some element of the MWD out, and I can select that, and I can take that out, and so there we go. We have already got our bottom hole assembly ready for this particular run, and we can go on. Now I'm going to come back here to the bottom hole assembly information, and I am going to delete that BHA number 6 just so I can show you how that is done. I go ahead and I select BHA number 6, and on the left-hand side here, and I press the delete button, and it says, do you want to delete it? And I say yes. It's important for me to go and select the last bottom hole assembly so that it knows which bottom hole assembly I'm currently looking at in my analysis. Now, if we want to add a bottom hole assembly from scratch, we would come over to this part of the screen, select the area that we want, type in the BHA number that we're going to use, and then type in the description. Say that's BHA number 6, and we have that selected, and then we hit the enter tab key, and we come back and we make sure that it's again selected. The next thing that we do is we go to the BHA items, and you'll notice that the BHA is already selected, the item BHA item number 1, and all we need to do is come in and select the kind of bit that we have, and let's say we have a PDC bit, and then we would type in the serial number or select it from the inventory that we already have built up if we have one, and then those items get put in. And so then we could fill in this information about top connections. If we have a 6.5 inch, so we'll say we have a 4.5 inch regular. And then our bottom connection would, of course, in this case would be none. And so then we could come over to the extreme left and under where it says item number, and then we would select the next item. And in this case it would be a motor. And we'll say that it's a steerable motor, and you should see the diagram. And now we can come over here, and again we have a drop-down list that we can choose from. And I'll say it's this particular motor here. Anytime we want to adjust the width of the columns, we just go to the top of the column like you would with Excel or just about any spreadsheet, and grab it like that, and then pull it over to where you want it. And then we put the ID in, and we would continue on building our bottom hole assembly up until we were finished. You should always put your drill pipe in as well as the very last item, because the program uses the drill pipe, of course, to calculate the total amount of weight. And if you want to delete something, you just go to the left and press delete. If you want to insert something, you go to the item where you want to have it inserted, and then you press the insert key, and then you insert your item. We are going to discuss how we calculate the hydraulics. There are two buttons that you can get to the hydraulics calculation module from. One of them is here under the BHA. You have this button over here for the hydraulics, and the other one is in the BHA items, where you have this button as well. Either one of them will do just fine. Before you calculate your hydraulics, you should make sure that all of your ODs, IDs, and lengths are properly filled in and that they're rational. Now, there are some limitations to how you can put fractions in. For example, if I want to put in a fraction here for 2 1/4, I can go 2 and 1/4. That's not a problem. But if I go 2 dash 1/4, that presents a problem. So don't put a dash in, put a space in if you're going to use fractions. Otherwise, just use the closest fraction that you can. The program doesn't have problems at all with fractions. Make sure that all your IDs are in there. For bits, motors, and MWDs, you can get away with putting in a 0 ID, because that's it assumes that those effectively don't have pass-through IDs, although they have effective IDs on them. But the program will assume a value. And then the ODs are very important. The OD and the hole diameter have to be in agreement with each other. But obviously the ODs of everything in the hole have got to be smaller than the hole itself. And then the lengths are all input, except for the very last length, which is calculated. But the hydraulics program will allow you to put in different lengths. It doesn't use this length. It uses the length that you input. So once you're satisfied that all the data that you have in here is correct, then you go and select the hydraulics button. And the hydraulics will come up with a screen, this screen right here, and it will lead you around by the nose in kind of an illogical pattern as to filling in the data, and when it is happy with having you put in all the data, then it will go ahead and do the calculation for you without any problem. Now, what this program does is allow you to specify the number of jets that you have, and then you can adjust the jet sizes with these sliders here, and then the TFA, or total flow area, is calculated for you. You may get a message sometimes. The program uses very fast iterative technique to calculate and go in on a flow. And if you want to calculate and see what your optimum hydraulics horsepower or impact is, you have this diagram over here, and this black line represents flow. Flow is represented here in the horizontal, and in the vertical you have maximum impact and you have horsepower in the red. So if this black line is anywhere in these regions right here, then you have optimum flow rate. Basically what that means is that you're getting an ideal amount of energy to the bit, and as you increase your flow rate, it basically has to do with the maximum percentage of the impact or the horsepower that you can get to the bit based upon your flow rate. And that isn't always applicable depends on the bit, and it depends on the size of the pipe. If you're drilling with small pipe, then this number is going to be pretty much not rational. And then, well, it'll be rational, but it's not. You can't do anything about it. You just have to maximize your flow rate and get your cuttings out of the hole. So the other things that you have down here under your controls is you have two different types of calculation models. Power law is the one which is most useful for calculating water-based muds, and Bingham plastic is the model which is most useful for calculating oil-based muds. Both models, however, are somewhat dated, and many of the mud companies have their own rheology models for calculating how pressure drops, and they haven't necessarily made them public, but you can always do adjustments in order to get your calculated numbers to get near to the actual values that you're seeing. And one way of doing that is the fudge factor method, in which you come over here to the pressure drops, and you have surface casing, which is explained here, the 4 different cases for the size of surface equipment, the pressure drops you get with your surface equipment. Then if you're using an MWD, you can put in an MWD drop and your motor drop. And if you're using a motor that is using the flow of the fluid to cool the bearings, then you can put in the percentage of fluid which is used to cool the bearings there, and that'll be taken out of the total flow calculation. And what you can do here, if you want to try and get your numbers to be more in line with what you're seeing, on especially using the oil-based muds, change the MWD drop to something which, it may not actually be that, but it will bring your numbers in line closer to what you're actually seeing, or your motor drop, one or the other. That's and that'll be sufficient, but really can't do much to change that unless we have access to the actual rheology model that's used for the particular kind of mud. And for whatever reason, the mud companies consider that to be proprietary information and don't generally allow people to have that. Then you have the report that you get printed out, and you can print the report here. And the report's a one-page report that puts everything in focus in the middle of the page. That's the most important. You have your flow rate, your pressure drop, your hole depth, and all the stuff in red, which is the most critical information to know. And you also have, if you have jars, it will tell you how much weight you have below your jars, or how much total weight you've got in your whole string. If you don't have jars, it won't tell you that. And those weights are only going to be as accurate as the weights that you have actually entered for the items that you have in there, or have been calculated for you. The casing profile is here. The bit data here is logged here. If you have in fact gone ahead and checked out the bit and put in the coding for it, then you can get that printed out here. And this is the only place where you can print the hydraulics report. It doesn't, even though there's a spot in the menu system for the reports that says you can do it, it doesn't actually work. That you have to come here to print the report. And then you have this area right here, which is the area where you can see your annular drops per component. So if your numbers are funny, you can go through and you can look at these numbers, and if you see a number that's way high or way too low, then you can go back and correct the underlying data. And this is the hydraulic summary, pretty much of the same order of what's in the middle of the hydraulics report. If you see something here that is amiss in the ODs or IDs, then you go back to the BHAs and you make your corrections to the underlying data here, and then you can return to your hydraulics and it will be calculated. One thing you need to do also, very important, is to put in your casing information. If your casing information isn't put in, then the program's not going to calculate things properly for you. If your ODs if the IDs of your casing are out of whack with the ODs of the stuff that you have in the hole. And then you have your annular geometry here, which tells you what's turbulent and what's laminar based upon the flow model that we're using. And then you have a lookup table here to give you ideas if you don't really know what the numbers are for different kinds of mud. And this is a dated table. I don't know how accurate it is, but it should be somewhere pretty close. The ranges that you have for plastic viscosity and yield point and funnel viscosity, and those elements are different weights of mud. So that pretty much summarizes the hydraulics report. And I guess to reiterate, the main thing that you want to do with the hydraulics report is let it lead you around by the nose when you put in the data, when you go into the screen. Make sure that all of your data here is correct. Number 3 would be to make sure that you put in your casing information, and number 4 would be to make sure that you put in your pressure drops for your other elements such as the MWD and the motor, and then just double check your numbers and make sure they're rational. And it's pretty easy to use once you get used to it. It's a little bit of a finicky program to get going, but it's once you have it set up properly, it's very easy to calculate your hydraulics from there on out. Now we are going to begin a discussion of daily activity editing. This program is part of the program which a directional driller uses more than any other part of WinSURV2 because they have to put in their activity, what they're doing over the course of the day. So knowing how to use this effectively is very important. In order to understand the structure here, let's first discuss what we have here. Over here we have a daily tab and we have a daily items tab. I'm going to show you the daily items tab. This is where you put in your data. It's a spreadsheet-like interface, and then on the daily you have a series of sub-tabs, and the information that you put in on this screen is the stuff that doesn't change over the course of a day. So you'd have a directional driller and the name of the people, the name of the mud company, things like that aren't likely to change. And then you have an area, a tab here where you can type in an extended comment. And you can get pretty verbose on these comments. There's no limit, but there's a formatting limit perhaps that you want to abide by for the way the report gets printed out. And then there is the daily summary, which is just a review page that you can get quick numbers from if you need to. And then there's the cost section if you're going to be using WinSURV2 to do your invoicing. And we'll go over each one of these in detail over the course of this next lesson. We're going to start off here by returning to the Date Info tab here under the Daily, and you can see that we already have some information in here on this particular day that we're at, but I'm at the end of a 24-hour period that I've filled out over here, and I have to start a new day to start a new 24-hour period. You can have your reporting done from different, like if you want it from 5:30 in the morning to 5:30 in the morning, you can change this report time here, and the reporting that is done will be generated across that period of time, but the interface here is always for putting things on a calendar date. So we're going to start here by clicking. What you have to do to initiate a new day is click on the calendar. It should be blank, as opposed to having the blue outline, and it asks me if I want to add a new day to confirm that that's what I want to do, and I say yes, that's what I want to do. And then it clears the screen for me and allows me to type in new information or copy the previous information by clicking this button right here and then updating that information to make sure that it sticks. And so I have initiated a new day, and there's nothing in here that I want to change. If there was something, maybe the name of the mud company or the name of the geologist or whatever, I could change those things and update them. But so for right now, I'm pretty much at the point where I want to begin my activity over here by clicking on the daily items and then getting over here and then going to the extreme left and then clicking here. I should always go to the extreme left just like you do in WinSURV2 BHA sections, and it starts from time 000 to whatever time. So I'm going to say for the first hour and a half of that morning from 0100 to 0130 I was circulating, and I can either select it by doing the drop down or by going ahead and pressing the number 3, and it will automatically select it for me. And when I leave the activity code, and this is an important thing to remember, when I leave the activity code, that's when it copies over everything from the previous line, because there's a lot of information in each line. And that information you don't want to be typing in every time, obviously. You just want to put in your times and depths for the most part, and if you have some change in your weight on bit or standpipe pressure or something like that, you can update that. But all of the other temporal data, such as the information that we have over here about the mud report, things like that, that doesn't really change unless it gets updated. But you do want to know when it changes, and so that's why we log it every time you put it in activity code here. Then the next thing that we would do here in order to add a new activity is we would come and we'd click on the extreme left here and notice that we have it has copied over this end time over to the start time here, which is a good way for you to check the validity of your times. And then you would just tab through that and you'd come over and we will say that we're circulating, and now we're going to do some more drilling. So I'm going to go to 0200 here, and we'll say that we were just rotary drilling and put in 1 there, and it automatically copies across information here about the weight on bit, GPM, and RPM from your last drilling activity code. Now drilling here is rotary drilling, and as opposed to sliding. And then we have the start depth, which again is cross-copied over here from the end depth to the start depth. And then we tab over to here, and we're going to put in 21. We're very deep here, so I will presume that we have some rather slow drilling going on here. And we're going to put in 25 for 55. Okay, so we drilled 10 feet in that interval, and now we'll come over to here, and we tab through. Now I can continue on putting in information here for BHA number 9, and then I can put in 0300. We did some reaming. Okay, so we had to come back up and clean the hole up and whatever. So we would come in here and said, you know, expanding hole. Just edit this right here. Now, what happens here is that we have this activity code, and you have the comment. The comment's what gets printed. The activity code is very important because that's where the summarization logic is for deciding what we are going to summarize in terms of hours below rotary, circulating hours, and things like that. Some codes, obviously, such as going in the hole, don't have circulation turned on. But so when you stop and you fill the pipe, then you would put in code for circulating, filling the pipe, or whatever. That's circulation code. So those all get summarized automatically for you as you go ahead and put your data in. And then we have here, we've put in for reaming, we may want to say what section of the hole we reamed, but we wouldn't necessarily put that in from start depth to end depth. We'd say we reamed from, say, you know, we reamed from 2100 down to 21,000 down to 21,555. So we pulled out of the hole, you know, a few stands, and then just reamed down, just cleaning up the hole. And notice that in this case, when I tab over, we have the appearance of these boxes here, and now we have the stuff in the form mode. And you will only see that when you're edit mode as opposed to add mode. I'm going to close this out right here, and I'm going to illustrate to you the difference between the two. Notice, keep your eye over on these little ellipse boxes here, and I'm going to click on here and notice that the ellipse boxes have disappeared. And that signifies that we are now in an add mode, and I'm going to come back here and I'm going to put in to 0500. We were 1 drilling, and when I put 1 in there, it automatically copied all that information over for me. And so I can tell it now that I drilled down to, say, 21,600. And I've basically finished my input for that activity. But let's say that I'm looking up here at the line above, and I notice that there's something on here that I need to change. And so I have to click, maybe do a click on one or two different things before I get these ellipse boxes to appear. And now I can go ahead and hit this, and I bring up this form here, this dialog form, which allows me to change whatever I need to change. Perhaps I needed to change what my RPM was. Maybe I was drilling at 100 RPM and I wanted to update that. So I would change that, and then I can update. So then that's been updated in this column over here. Another thing that can happen is that I can start an activity and get interrupted before I do the copy over. So I'm going to come over to here, and I'm going to 0500, let's say from 0600, whatever, and I get distracted. Something happens, and the door opens, company man wants to report, or I need to go up to the floor, do something. So at any rate, I get distracted, and I come off of here, and when I come back later on, I come here and I say, oh, okay, yeah, I was sliding ahead. I was doing some sliding there, and then I go put in my sliding code, and then I hit my tab, and lo and behold, none of the information that I have here gets copied over. So I've got a bit of an issue there, because I don't want to type in all that information all over again. But notice that I have the ellipse box here that has been lit up, and I go, well, okay, I can go ahead to this, and I can copy previous, and it copies all the critical information over for me, and I go update, and now I have all the information in here except what I was doing, sliding, slide with whatever comment that I would want to type in. And when I come over to here, I can type in my 615. So I slid for 15 feet for some reason. And so I can go on. But it's important to remember that that's how you can do things. Now, there is an occasion where you will get hung up and you can't add any more lines. And that what's happened in that case is that because of some underlying problem in the database, it's gotten corrupted, and it won't allow you to update or anything that you want to do. And it's important, it'll tell you that if you can't get out of that particular mode, that to go all the way out of the program and then go back into it. So I'm going to illustrate what going all the way out of the program actually signifies here. And going all the way out of the program means that you come up here and you close this, and then there's this delay, and then you will come to this screen, and then you go all the way back to the main screen here. And at this point, I'm going to rerun the daily BHA. And I'm going to go back in to the screen where I was, and I'm going to go back to the daily items. And if there was a line that was giving me a problem, I can try inputting information on it, or I can simply select the line on the left and delete it. Now that's a useful function for me to have. And to be able to delete, but I can also insert. Let's say I forgot to put in a code here in between here, so I would come and I would select here, and I would press the insert button. I need to find the insert. Press that, and notice that it has inserted a code here between my 0400 and my 0300, and I can change this around. So I'm going to go to it says 0300, and I can change these times to whatever. But if I change, any time that I change here, let's say I said I had something from 0230 there, and I would have to come up to the line above it and change that line, and then come down to here and change that line. So it's a little bit, when you insert stuff, you have to keep in mind this cross section of times here in order to get this correct in here. And I can say maybe that I was just circulating right there for a while. So once I get that in there, then I'm okay. Now notice too that as we are putting information in here, we're putting in information about when we're drilling and so on, and the depth and the information, the mud weight and all those things that we put in here is important because it's a matter of record, but it's also used in the program as we will continue to expand our BHA, likely as you add daily items. And you'll notice that you have the BHA number 9 over here, and there's other information which is used in the calculation, such as the mud weight. So if we venture to the right over here, you'll see that there's a mud weight in here that's used. This depth is used, and the calculation is made based upon that information for what your neutral weight is. It's also useful for you to have your drill pipe all the way properly calculated if you're going to be calculating your hydraulics. So one thing, it may be a little bit annoying to put your drill pipe in for a bottom hole assembly. However, it's kind of necessary to calculate these other things so you can know what your weight is, what your wet weight is, and all those items. Now we're going to progress forward here. In order to see what your current neutral point is based upon the current parameters you're drilling, you would come to this point right here, and where it says click here to show neutral point information, and click on there, and then it is spelled out for you what the point is. In this case it says we have 10,000 pounds weight on bit, and we got 482 feet above bottom. Now if you're working in metrics, this message will be in meters, and this weight on bit would be in metric tons. You can see also in this area right here just below, I had my little menu pop up there for a second, the information about the total string weight and wet weight is also displayed there. So that's a valuable piece of information for drillers, knowing where they're at, especially if you're in a situation where you're putting a lot of weight on. You want to control the neutral point.